Welcome back. Today we are going to discuss about something called Industry 4.0. Now this is more of a very much a broader topic, and maybe it may not be interesting for us in a specific way because as a community we are basically academic researcher or maybe researchers uh, doing research in, let's say, an industrial environment. But I will say that as we get more experience, then we should have more broader picture or gather more broader information about our field and all this thing. So in that context, I feel like this may be important. So industry 4.0 is a terminology that used uh, specifically for the changes that the various industry or manufacturing facilities, or the manufacturing companies are going through due to the information age and internet and all this thing. So we'll try to understand that, and specifically, of course, this is more relevant to big businesses, not for us, let's say. Not really exactly for us, but there is no harm in understanding this generic concept and what it means. Maybe we can have a thought about what it means for us as a community. Like we as a community is defined as like maybe a professor working in a university, or professor working in a spin-off, or a researcher working in an industrial lab. So yeah, so there is no harm in knowing this generic concept, and certainly these are new thing and very hot topic. So we'll try to understand, and I'll try to do a justice here. I'm not saying that I'm expert on this thing, but certainly I'll try to explain as much as possible. So what is Industry 4.0? It's about advanced manufacturing. So now we are in a different age where we have various interesting technologies like additive manufacturing, which means basically 3D printing, and then advanced material. For example, now people talk about using like, for example, rockets are made with a very light material. The outer casing are made with a light material, but those are very hard. So that's an example of advanced material. Then smart and automated machine, IoT, information of things, which are basically devices that you can I'm not an expert on this thing, but by definition these can be any device where you can attach it with a system, and that system can be any machine or even the human body, and then you collect the data, let's say, in a longer term or more of an online basis. So and smarter supply chain is also part of advanced manufacturing. Now the big businesses, they have to incorporate all these new technologies into their manufacturing, otherwise they will perish, because they may not be able to sustain their businesses, because there will be competition. If they do not do that, then their competitor will do that, and then they will have a better edge in the making the same product with a lesser price and all this thing, and then they will be out of business. So that's the, very simply speaking, the Industry 4.0, which is why it is called 4.0, because the report or the document from where I'm making this video, they talk about so I will explain that later, but I just give you the basic information. They talk about industrial revolution, and this is the fourth revolution that we are going through. And in simple sense, Industry 4.0 is basically a marriage between the digital or the information technology and the existing, the machinery, whatever it is. And what they argue is that whoever is going to use this information or their feedback simply speaking, from their devices, or sorry, from their products in better way, they will be successful. And in that context, so this is document, I mean the material from where I'm making this video. This is a document from Deloitte, I think that's the right pronunciation, and they talk about something called information value loop. They say that it is actually, the information is in a feedback loop, and whoever is going to use that information in a correct way, they will succeed in making a competitive business in this new age. So, and new age is about gathering data from your product and using it to enhance your product and make it more competitive in the market. So yeah, and there are similar terminology, or I mean industry 4.0 is a term that they had used here, but then there are similar terminology used to explain the same thing. For example, industrial internet, connected enterprise, smart manufacturing, smart factory, manufacturing 4.0, etc. Yeah. So as I said, industry 4.0 is basically a new type of industrial revolution. And if you see, so first this particular term, I mean Deloitte is using it, but it was coined by someone, Hanover Messe. It was coined at the Hanover Messe trade fair, and yeah, and according to Germany Trade and Invest GTAI, the definition of industry 4.0 can be a paradigm shift made possible by technological advances which constitute a reversal of conventional production process logic. Simply put, this means that industrial production machinery no longer simply process the product, but the product communicate with the machinery to tell it exactly what to do. Yeah, so that's a more fictional way of telling the story, but in a technical way, it means that you are actually gathering information about each and every step of a process, not just like delivering the product and then get the feedback from the customer or something like that. That may be also a part of the process, but also the manufacturing itself, how it goes on. So again, I'm not going to not be able to, honestly speaking, give you a solid example as such, but all of us can guess what it means. Yes, to further explain, GTAI further adds that the industry 4.0 represents the technological evolution from embedded system to cyber physical system. So now the system, they'll all have some sort of IoTs and all this thing, and they will collect the data and try to give you information about the manufacturing and what are the problem, what are the new domains one can explore and all this thing. So an approach that connects embedded production technologies and smart production processes. To eliminate its concept of industry 4.0, GTAI invokes the concept of cyber physical systems, CPS, technologies that marry the digital and physical world, typically via sensor affixed to physical devices, and networking technologies that collect the resulting data and subsequently analyzing the data and coming up with a different kind of decision that okay, now next time we'll go through in this process and all this thing. Now and also they talk about industry 4.0. They say that it's actually physical to digital to physical leap in the manufacturing, where physical means basically you are building a physical product, but then the point being here that all the manufacturing that you do, at least nowadays, all will start with some design that is inside a computer. People or engineer is making a design in the computer, and then they are doing research and all this thing, and then those specific information about the parameter, geometrical parameter, etc., on all this thing will go into the machinery input, and then they will come up with, or they will produce the, from the machine they will produce the product, or some part of the product. So there is always a digital aspect prior to physical form of the product, but it is not just physical, digital to physical, but also physical to digital. That means after manufacturing also you do lot of experimentation, let's say. So maybe I can pick up some example here. So let's say I work with, or my research group work with a company, and they do make a lot of stuffs, not by themselves exactly, but they do more of a research, and then they basically order, for example, they use in their scanner collimator, something called collimator, and those are very heart of the technology actually. In fact, so much so crucial and so much so important that they don't want to see let other people see what the designs are actually. So they wrap it with a black tape actually. So that's very interesting. But anyway, so I'm the insider guy here, so I can give you some basic information at least, but it's not something too much of a something that nobody knows, but it's all in the research paper. But still, whether it will work or not, that's always a question. So one can think about any number of ideas, but then to do research onto that and come up with the design and all things, and again ordering on that basis of design, and then and having a physical product or physical equipment like here collimator, and then testing it whether it will work or not. So that's a huge investment, I will say. So to give you an example, so here digital starts first, and then of course physical comes, but then after physical will get a collimator, then of course the next step will be to do experiment, because even if we do a lot of simulation and experiment and maybe analytic calculation, previously it used to be a lot of analytic calculation, now research is more driven to because of the computational resources and availability of a lot of very high-end softwares, people do more of this Monte Carlo simulation and all this thing. But still, you don't, even if after the first manufacturing of the exact, let's say collimator here in this example, you don't know like whether it will work or not, whether it will give you the good resolution images or not. So you'll test it actually. So after doing a test, then you will get a lot of information. We thought about this thing, but it's not happening in this way. So then comes the digital part, that means physical equipment giving some more information about which you need to incorporate into the digital architecture. That means here again you'll into the drawing board, that means you will be designing again, and then again you will do and then again we order it depending on updated parameter maybe. So that's again going to physical. So that's this balancing or hopping from physical to digital and digital to physical will happen, and that's the way you build a successful product actually. So even if you your software and design softwares and all this thing will reach a very high efficiency end, but you'll never be able to say with 100% certainty that this is the way it will work and you don't have to do anything else. There is always a value for experiment. So that's my example in whatever I do in my research. So but in industry there is huge spectrum of thing that one can think of about this idea or concept, that physical to digital and digital to physical leap, which is the nature of the industry 4.0. And how this happens with the integration of various cutting edge technology like IoT, which are there for a long time, but it had not been so powerful. Right now it is so powerful actually, because one of my friend actually worked in IoT and all these things. So they publish in a lot of high impact factor journals and all thing. And I can see that, very small thing, I mean, from a college student point of view, doing research or doing physics or doing maybe engineering, maybe about doing something fundamental or maybe black hole and all this thing people talk about. But then even simple thing like, making a window of window glass which will doesn't reflect the light or something like that, these are small things that are part of the IoT, I mean becoming part of IoT, because you can do that actually. So those are called smart glass. Oh no, I don't remember, but there was something like that she was working. So I'm just giving you an example, but you know that this IoT is a big thing. And then analytic, that means analyzing the data. That's also, especially the big data, that is the important part, because when you are doing this thing in a big manufacturing hub, then data will be produced in big huge way, with a huge amount. So then you need special techniques. Then additive manufacturing, that means 3D printing, that is a buzzword, and I think in aerospace and defense sector, this is a big word actually. People talk about and don't just think 3D printing means just those YouTube short or TikTok videos where people show you, how to make toys with 3D printer and all this thing. No, 3D printer will act or I mean will work with the, let's say, with molten material also, like maybe I'm not sure, but I think it will work with the iron also, like so it's a very effective technology, and people are looking into a huge amount of disruption in near future, where various businesses will be replaced if not they update themselves. And then robotics, so I think now since I'm from health background, so I know people talk about robotics, using robotics for surgery. So they show that compared to a surgeon, I mean not related to the making a big decision, but certainly if you can give the computer or the software a very specific information that you have to cut this portion and do this thing inside, I mean, and then you stitch it up. So they're showing with robotics it can be done with huge amount of precision, maybe 10 or 5 order of precision, better precision than, let's say, human doing thing with their normal eyes actually. So that's the robotics in progress of robotics from from healthcare point of views. But certainly robotics is there in the industry and manufacturing hub also, where they do a lot of part of the manufacturing will be done by robotics. And then high performance computing, that's part of the analytic and all this thing. Artificial intelligence, that's also important. Cognitive technologies, advanced material, that's very much important, because we know that being from physics background, I know that most of the physics department in not just in India, but I think in throughout the world is, I think 60% of the physics department researchers or professors are from material science. So and of course if you see the outside world, so certainly material science is the important aspect, so one of the most important aspects. So certainly that will going to be popular, and augmented reality and all this thing. Now here in the figure you can see also how this what it mean by physical to digital and digital, and then digital to physical. So there are like technologies. So so for example, from physical to digital means where the sensors and controls will be used, then wearables will be used, and then augmented reality and all this thing. So I think augmented reality in case of Facebook's metaverse, these things, so they also do a lot of research into that. So one example can be like, so they built this device, where wearing that you can talk with the other person who will be wearing the same device, but you will both of you will be distant apart, let's say in long distance, like it's like it can be anywhere in the world. You guys can be anywhere in the world, but the augmented reality will give you the feeling that that you are sitting in front of, both of you are sitting in front of each other. So there was an interview of Zuckerberg with Lex Friedman. So yeah, so that can be an example of physical to digital, where the improvement of device needs input from the experiments or whatever the customers is using it. So then that will be updated. For example, in Tesla also, that's a good example where in the automated car itself, it's everything get updated with time, within, I mean, each year the software get more powerful. So yeah, now digital can be in the digital phase, then you need to process the data like signal aggregation, optimization, prediction, visualization, and POS delivery, cognitive and high performance computing. Then now digital to physical transformation is about then additive manufacturing, advanced material, autonomous robotics, digital design and simulation. So I will add digital to physical fast, but anyway, so that's the basic about Industry 4.0, what it means. And yeah, this is a figure of different industrial revolution that happened in past, and the term Industry 4.0 basically means it's the fourth industrial revolution they are talking about, or at least they think of. And interesting to note, or maybe good to recall it, remember that what industrial revolution was in various stages. So in late 18th century, it was initiated by production of power loom, and mechanization of production facilities with water and steam power. So, and it started in Europe, especially in England. Second industrial revolution, where introduction of the assembly line in slaughterhouses in 1970. Yeah, I think slaughterhouse, I think it's a generic term they are using. Electrification drives mass production in variety of industries. So first industrial revolution is about power generation through steam engine, water and steam power and all this thing. And then second is electrification, and third is that happened actually 1970s and 2000, and that was about development of the first programmable logic controller and growing application of electronics and IT to automate production processes. So that I think we know, and I think this is the only revolution that we are to some extent as a country, as a society, we are to some extent in part of it. But the last two are certainly we are not part of it. The first revolution in 18th century that happened in England, and that's why they are the mighty power. They captured most of the part of the world through that, and to the profit of this revolution, industrial revolution and production and all this thing. So I came from my house, I'm from Bengal, so we know that from my school we read that how the cotton industry had been destroyed to make the product coming from England more successful, which when you are basically under someone's rule, you can't really do anything. So that's the reality. But anyway, I'm not really talking from that, not that a negative point of view as such, but that's the part of the history. We all need to accept that as it is. But anyway, and beginning of the 20th century, electrification, that's also we are not part of it. That happened US and Europe to some extent, I think. Yeah, certainly third one is we are
to some extent part of it, because we are that time we are in 1970s and 2000 we are to some extent independent, or not, certainly we are independent as a country, but we are not, of course, industrialized, because we missed this last two phases. So certainly the third will be not so easy to integrate. I think we as a country, we are not that industrialized. Certainly, that's my personal opinion. Anyway, and the fourth one that we are talking right now is basically integrating the various information technology and internet and IoT devices, and then do the additive manufacturing and etc. Increase of cyber physical system. In January 2021, Industry 4.0 was initiated as a future project by German federal government. So we know that Germany is basically the production or manufacturing hub of Europe, and certainly China is in a different league altogether. Yeah. So with the introduction of IPv6 in 2021, virtually unlimited addressing space become available. So I don't know what is IPv6. Maybe I will know about it later. Governments, private companies, and industry associations have been focusing on Industry 4.0 and making investments since the 2010s. So that's the context of Industry 4.0 in context to other last three revolutions.
Okay, so this is a schematic of information value loop that they are proposing, and you can see here the light blue means stages of communication, and deep blue means value drivers. That means it can be magnitude, it can be risks, it can be time. Magnitude basically means scope of technology or the product and all this thing, and scale and frequency. Risk can be related to security, reliability, accuracy, and time can be related to latency, timeliness. Now various stages are can be connected through various technologies, like act and create stage can be connected through sensors. So act basically means act of creating a product, and then after creating, in between creation of that, so you can use sensors to automate things. So I think that's the meaning here. And then after creation of then you use a set of technology to collect data when the customers are using it. So that's kind of an example I'm setting, but yeah, so these are actually more generalistic picture here. It can be different in different industries. And then after communicating, you basically aggregate the data, and then you analyze it, and then depending on the analysis, you basically change your action. That means your design or something like that. So that's more or less is a basic a simple way of explaining information value loop. And if you want to know more about it, so you can read more literature on that. So that's the very simple picture of information value loop. Okay, so before understanding Industry 4.0, let's revise what a manufacturing value chain in generally look like. So in a simple sense, basically it start with design and development of a particular product, and basically done by a bunch of engineers, scientists, and of course other people and then it will, the design and development or research and all this thing will go to a first prototype and maybe an improved prototype, and then it will go through manufacturing, and then it will be in the sales, and then after, if it is needed, there will be services for the product, yeah, whether it is a business B2B or B2C scenario. That means business to business product or or business to customer. So that's very simplistic picture. I mean, again, I'm not reminding yourself that trying to remind you that that I'm not really an expert on this thing. So I just reading, or trying to learn various things related to these this thing. So now from a classical point of view, one can see business as a set of actions, or set of rules, or set of strategies where you focus on operating a business, and then and making sure it is sustainable and all this thing, and then you go on taking measures to grow your business. So from business operation point of view, there are two categories you can think of: productivity improvements and risk reduction. That means you are doing small innovation to your product so that it is more refined, maximizing asset utilization and minimizing downtime, driving direct and indirect labor efficiency, managing supply network cost and synchronization, ensuring schedule and plan stability and accuracy. And then in the risk reduction phase, you can think about ensuring raw material price and availability, managing warranty and recall effectively, mitigating geographic risk. And now in the business growth phase, that means, or in the frontier, that means you are actually increasing the potential of the business and finding new territories. So there you thought about incremental revenue and new revenue. So finding sources of growth for the core business, growing at aftermarket revenue stream, deepening customer understanding and insight, strengthening customer integration and channels. So that is incremental revenue generation process. And new revenue is basically where you basically move into new direction, where you can be creating new product and service offerings, expanding internationally and in emerging markets, identifying attractive M&A opportunity. I think management and administrative opportunity, that's what it means. So this is the classical picture, and now we will see how industry 4.0 technologies can integrate or into or fix can be used into the same framework to produce better result. Now in the same classical picture, here you can think of you can use industry 4.0 technologies in the business operation, where in the planning phase you can predict changes and responding in real time. So these are actually very general generalizing things, but in case of your business or your company or your product, it can be different, and something can be absent, so in case of factory, creating a digital link between operations and information technology. In case of support, automating and scaling aftermarket operations. So again, these are very general statements. And in case of business growth, how industry 4.0 can transform picture. In case of product, creating or augmenting smart products and services. In case of customers, connecting and integrating in new ways. And the engineers, accelerating innovation and design cycle. So we'll go into discussing this thing in a much better way. So we'll see how this industry 4.0 technology can impact various segment of manufacturing cycle. Now we will first discuss growing the business, that means opening new frontier, and how industry 4.0 technologies can help you. So in generally, product design and development can be enhanced through use of sensors, wearables, 3D printing, advanced computation and robotics. Yeah, so these are much general picture, and sometimes depending on your company or your product, this something cannot, some part of it cannot be used. But certainly industry 4.0 is a concept which is a basically is a truth that needed to be accepted by most of the industries, specifically the big businesses, where they have to incorporate or integrate these new technologies so that they can perform in a more competitive way. Now, how industry 4.0 technologies can transform products. So in case of marketing, already existing products making already existing product smarter. So for that you can do one can do add sensors and connectivity to improve product performance or safety, enable connections to mobile applications to improve the user experience, add advanced material to existing product to improve performance, offering the data generated from smart technologies as a product or service. So that also is another way to go forward and developing completely new product and services. So that also is possible. So developed cost-effective mass customization, enable new and hybrid product innovations through advanced manufacturing technologies, create new service format and business models. So that is about potential industry 4.0 applications for product transformation. Now there are segments where technologies can be used for engineering transformation, that means the design part and all this thing. Reduce idea to market time. So any in a lot of cases basically the first prototype making takes time because of the R&D and all these things. So there one can use various industry 4.0 technologies. So use rapid prototyping production capabilities to design new products and eliminate supply chain dependencies. Continue new software solutions through cloud enabled development tools. Better link design to product intelligence. Use data to anticipate design flaws and correct for them. Design products and simulate usage based on total cost of ownership and supply implications. Evaluate product design options based on manufacturability. And then improve the overall effectiveness of engineering. So there are also techniques for that. But I think I will rather just give you some example how this had been really done. For example, first stage of manufacturing value chain focuses on R&D and design area where industry 4.0 can accelerate and improve the design cycle, reducing time to market and linking design to smart products. Yeah, so let's go into examples at in one such example, OT and IT are being used in mass customization of medical implant. So IT means information technology, and OT, I think, I don't remember exactly. Devices need by many individual, but each with its own unique geometry and circumstances. So at its 3D Medical Application Center, 3D MAC, Walter Reed National Military Medical Center manufactures prosthetics by scanning the patient's individual anatomy, enabling it to use additive manufacturing technology to fabricate a fully customized fit. So that's the industry 4.0 sort of a concept where basically it means that that they are going to the customer and using a medical technology to scan the anatomy and then create a unique product which can be fitted, or it's a custom fit product. So other example is researchers at University of California and architected material are developing technologies to improve protection offered by football helmets. By taking a 3D scan of players' head, helmets can be built to individual measurements. So that's a similar scenario. Similar case, yes, there is an example for business to business setting also. General Electric's power and water division is implementing digital twinning for the parts it supplies to power plants, wind farms, and electrical grids. Using sensors and control signal aggregation and HPC, it is developing real-time signal simulation model of its real-life physical parts operating within the plant. So that is digital twin. I think I know this concept, so from something related to this. And basically it means that the hardware basically will going to have a lot of sensors, and they will be collected with they will be collecting data in real time, or at least in some sense real time, maybe if not 1 year, but I think 1 week or maybe 1 month after all the data will be connected. And they have a simplified software design where all this data can be fed, and the performance of the system can be monitored through, and the software design basically underlying it, there is a sort of modeling and mathematics goes on, and that will predict a lot of thing that what is the stage of it and whether it is going to fail or not. So I remember that this kind of digital twin technology, I think there was something discussed in case of Siemens product, where they are talking about having a digital twin of the railway railway engines that they are basically not providing, but I think they are actually creating software or digital twin for the some railway engine of some company. So that's the example I know for a long time back. So that's a very good example of industry 4.0 technology. And I think one can say for sure that these are not something new. These are to some extent known, but industry 4.0 is a sort of a terminology that had been coined, and under that everything similar to, this kind of thing had been incorporated, so that people can have a more bigger vision that these are the new changes that are happening. And every businessman or every manager or every technologist or every scientist can think from that framework, that whatever invention they are doing, whether it can be, it needs some design change or something like that, from the point of view of the industry 4.0 technologies and all these things. So that's the goal of coming up with this new terminology. So that's all about this slide. Few other example of growing business from the point of view of the engineers and scientists will be where so use of digital to physical manufacturing technology such as additive manufacturing is in rapid prototyping can speed up the design process as well as the production of end use products, thus reducing supply chain dependencies. Ford estimates that its use of rapid prototyping during vehicle design can save its weeks, with additively manufacturing prototypes taking hours to fabricate rather than the 4 to 6 weeks that taken by typical machine tooling approaches, bringing automobiles to market months earlier. So that's an example. Another example, John Dairy uses augmented reality to allow customers to test and provide feedback on early design concepts so that it can adjust and redevelop designs. The company estimates that having its engineers use virtual reality simulations to design the air handling subsystems on its JD7760 cotton harvester reduces the design cycle time from 27 months to 9 months and reduced design cost by more than $100,000. Local Motors, for example, CrowdShares many designs among customers and enthusiasts in the community, holding design competition and allowing clients to have a strong hand in design of its cards. So that's the open source innovation, I will say. Yeah, now, so to be specific, apart from example, now if we focus on operating business, how industry 4.0 technology can help growing business, that means existing business, how we can operate it in a much better way. So that can be divided into planning transformation, planning based transformation, or and also as well as factory transformation. That means the factory that you have for the manufacturing, that can be transformed through industry 4.0 technologies. For example, in factory transformation scenario, one can use enhanced labor productivity and effectiveness, then production asset intelligence, activity synchronization and flow. Whereas in case of planning transformation, that means let me explain. It can be demand sensing and planning, supply planning and supplier transformation, outbound network optimization. So yeah, so that's it about operating business. Yeah. Now there can be, in depending on the industry, there can be a lot of challenges in accepting industry 4.0 changes or technologies into their way of doing business or making products and all these things. So one example or one category of challenge that they had discussed is lack of HR in planning. That means lack of skills or human resources. That means the particular expertise people who will be responsible for planning this thing and executing, and more importantly operating the new system. New system means basically whatever the large amount of data that had been produced, one need to analyze it and make decision on that, and a lot of people do not have and don't have that particular expertise. And I think it depends on the industry also. If the industry is big or your company is big and it has a large factory and all this thing and distributed in various cities, then of course it's a big it needed to be done by a professional, so one need to hire new people. And then other challenge will be less experience with additive manufacturing. So yeah, sometimes people have a lot of doubts, specifically the managers and the particular person who is responsible for taking decisions. So they will be they'll have a lot of doubts, and which is a natural thing. So that's also a sort of a challenge for transformation, and sometimes those doubts are genuine and sometimes are not actually. And finally, more importantly, is data ownership. So industry 4.0 basically talks about digital to physical to digital again, but the point is here, the whole more important thing is the data. That data we are capturing, data we are analyzing, and that from that whatever insight we are getting, we making new strategy on that. But if we don't have the ownership of the data, then that's a problem. So what do we mean by that? So when you are collecting data, for example, one example will be like your product have a lot of sensors and that are collecting data and all this thing, and so that you can improve your product and all this thing. And which happens with like in case of mobile softwares and mobile manufacturing maybe, and maybe a lot of apps also even. But the point being there that that whether you own the data, because in the value chain, manufacturing value chain, when it reaches to the customers, so they are generating data. So data basically, so they can claim that their data actually. So although you can have a claim that this is our product and all this thing, but it's a legal question, big question. And depending on the geography and country, a lot of legal system may interpret things in different ways. So that's a big matter of fact big issue actually, because the industry 4.0, the core concept of it is actually digital to physical to digital. So there the ownership is a big challenge, can become big challenge depending on industries and geographies also. So yeah, so that's it about the video, and this is the reference, I mean the web link from where I download this particular document on which I'm making this video. And if you like, then please like, share and subscribe, and see you in the next week. Bye.